the problem. Processing n jobs through 3 machines. Okay, look at the problem. There are 5 jobs, each of which is to be processed through 3 machines A, B, C. In the order A, B, C. This is the order. Okay. Processing times in minutes are given in the tabular column. There are 5 jobs, no? 1, 2, 3, 4, 5 and 3 machines A, B, C, and these are the durations. With this, determine the optimum sequence for the 5 jobs and minimum elapsed time. Also find the idle time for 3 machines and waiting time for the 5 jobs. Okay, so with this information, they're asking us to find out the first one, optimum sequence, and the next one, minimum elapsed time, and the third one, idle time for 3 machines, and the fourth one, waiting time for the 5 jobs. Okay, now see the solution. In order to solve the problem, first we need to check the condition. See, the first step is, here we have 2 important conditions. Okay, condition number 1 is, minimum duration of machine A should be greater than or equal to maximum duration of machine B. Okay, this is the first condition. And the second condition is, minimum duration of machine C should be greater than or equal to maximum duration of machine B. Okay, so these are the important conditions. Now, the first step is, in order to proceed further, we need to satisfy either or both the above conditions. That is, if either or both the above conditions satisfied, then we can go to next step. Otherwise, stop the procedure, which means the algorithm fails. Now, look at the problem to check this condition. Look at the problem. First, we need to find out the minimum duration on machine A and minimum duration on machine C and maximum duration on machine B. Okay, so here on machine A, the minimum duration is 6. Okay, see here, on minimum duration on machine C is 10. Okay, and on machine B, the maximum duration is 10. Okay, now see the solution to check this condition. See the solution. The first step is we need to check the condition. Okay, here we have conditions. For that, minimum duration on machine A is 6 and minimum duration on machine C is 10 and maximum duration on machine B is 10. Look at the first condition. The minimum duration on machine A 6 should be greater than or equal to maximum duration on machine B, that is 10. So here 6 is not greater than 10. So the first condition is failed. Now see the second condition. Minimum duration on machine C is 10. It should be greater than or equal to maximum duration on machine B, 10. Now 10 is equal to 10. The second condition is satisfied. Okay, we need to satisfy any one condition or both the conditions in order to proceed further. Okay, here we satisfied one condition. Now see the next step. Look at the second step. Here we need to introduce 2 fictitious machines. So fictitious means imaginary. That is M1 and M2. For M1, we need to club A's duration and B's duration, and for M2, we need to club B's duration and C's duration. See the problem. For machine 1, we need to club A's duration and B's duration. Okay, that is 6 plus 8, 16 plus 10, like that. Okay, for machine 2, we need to add B's duration and C's duration, that is 8 plus 14 and then 10 plus 18, like that. Okay, now see the solution. See the solution in step 2. Here we have 5 jobs, an imaginary mission 1, imaginary mission 2. Okay, for mission 1, the duration is A plus B, no, 14, 26, 16, 14 and 14. For mission 2, 22, 28, 12, 16 and 26. Okay, so after finding this, the next step is we need to find optimum sequence by using Johnson's algorithm. Look at the problem. First we are going to find out optimum sequence for the 5 jobs. Okay, now see the solution. See, in the previous video we have seen n jobs through 2 machines. Okay, by using Johnson's algorithm in detail. Here we are going to apply the same procedure for finding optimum job sequence. Okay, see, look at the table. What is the first procedure? So first we need to find out the minimum duration among M1 and M2. Okay, so find out the minimum duration. Yes, So 12 is the minimum duration, but it occurs on mission 2. So what is the procedure? If minimum value occurs on mission 2, we need to assign this particular job in the backward direction first. Okay, so assign this job in the backward direction, job 3. So we have assigned this particular job, then again we have to follow the same procedure. Okay, which is the minimum duration? Yes, 14 is the minimum duration, but it occurs on mission 1 for 3 different jobs. So this is called tie. In case of tie, what is the procedure? We need to check with the opposite minimum value and assign that particular job in the forward direction first, next, like that. Now see the opposite value, 22, here 16, here 26. So which is the minimum duration? 16 is the minimum duration. So assign this job in the forward direction first. Okay, the next minimum duration is 22. Okay, so assign this particular job in the forward direction next. 1. Okay, then next one is 26. So assign this particular job in the forward direction next. Okay, so we have assigned 3 jobs in the forward direction. Now we have only one job, that is job 2. So assign here. So we have found optimal job sequence by using Johnson's algorithm. That is for mission 1 forward direction, for mission 2 backward direction. Okay. Now we are going to apply this optimal sequence for the original problem. Look at the solution table. See the table, computation of minimum elapsed time. Okay, so here we have 3 different missions, mission A, B, C. Okay, and we are going to find out the in time and out time for 3 different missions. For that, we need to enter duration for 3 missions according to the job sequence. Okay, now see the problem. Look at the problem. Okay, these are the durations for 3 different missions for 5 different jobs. Okay, and we need to enter duration for 3 missions according to the optimum job sequence in the solution table. Okay, say the solution table, we have entered duration for 3 different missions according to the optimal job sequence from the original problem. Okay, now the next step is we need to find in time and out time for 3 missions. First we are going to find out in time and out time for mission A, since it is the first process. Each and every job has to process through A, B, C. This is the order now. Okay, mission A need not wait for any job. Okay, there will be no waiting time for mission A during the process. So we can enter in time, out time for mission A first. Okay, see the first job. Okay, the starting time is 0. Okay, so how to find out out time? In time plus duration is equal to time out. So 0 plus 10, 10 is the out time for the first job. For the next job, the in time is 10, because after completing the previous job only, mission A will take up the next job. So in time for the next job is 10. So 10 plus 6, 16 is the out time. Okay, for the next job, in time is 16. Okay, 16 plus 8, 24 is the out time. Then in time for the next job is 24. 24 plus 16 is equal to 40. Okay, the next one is 40 is the in time for the last job. In time and out time for mission A. Now let us see the in time and out time calculation for mission B. Okay, for that, okay, we have to see the previous process. So after completion of the previous process, the mission B will take up the each and every job. Okay, see for the first job, the in time is 10, because after completion of this process only, the job 4 will move on to mission B. So what is the in time? 10 is the in time plus duration 4. 14 is the out time. Okay, look at the next job, that is job 1, and its out time from mission A is 16. Okay, so here the previous job completion time on mission B is 14. So 14 is lesser than 16. So the mission B has to wait for 2 minutes to take up the next job. Okay, so we need to enter greater value as in time for the current job. For the current job, the in time is 16 minutes. So 16 plus 8, 24 is the out time. Okay, now 24 is the in time for the next job, because here we have equal value. So 24 is the in time. So in time plus duration. So out time is 30 For the next job, again we have to compare, because which is a higher value? 40 is a higher value, no? So this will be the end time for the next job. So 40 plus 10, 50. In the same way, for the next job also higher value, that is 54 is the end time. So 54 plus 2, 56 is the out time. Okay, so this is the way to enter in time and out time for machine B. In the same way, we need to enter time in and time out for machine C. Okay, so what is the end time for the first job? After completing the two process A and B, then the job will move on to machine C. So end time is the out time of the previous process, that is 14 is the end time, plus duration 12 is equal to 26. For the next job, just compare the current job's out time from machine B and previous job out time from machine C. Okay, so here we need to enter greater value as in time for the current job on machine C. Okay, which means machine C will take up the next job after completing the previous job only. Okay, so the in time is 26 and plus duration 14 is equal to 40 is the out time. For the next job, so which is the highest value? 40 is the greater value, no? So 40 is the in time, 40 plus 20, 60 is the out time. For the next job also, so which is highest? 60 is the greater value. So in time plus duration 78 is the out time. For the next also greater value as in time. So 78 is in time plus duration 10. So out time is 88. Okay, so this is the way to find out in time and out time for machine C. Now look at the problem. So far we have done two things. Okay, number one is we found optimum sequence for the 5 jobs. Okay, and the next one is we found in time and out time for 3 different machines. Okay, in order to find out the total minimum elapsed time. See the solution table. See the solution table. So here all the 5 different jobs processed through 3 different machines. Machine A, machine B and machine C. Okay. So entire process comes to an end in the 88th minute. Okay. This is the total minimum elapsed time. Okay. See, according to this problem, we have found total minimum elapsed time as 88 minutes. Okay, the next calculation is we are going to find idle time for machine A, machine B and machine C. For that, look at the solution table. See the solution table. In order to find out the idle time for machine A, just compare the total elapsed time with the completion time on machine A. Okay, so machine A completed all the process and the out time for the last job is 54th minute. Okay, but machine A has to wait till it complete the entire process. That is the idle time for machine A. So what is the difference? 88 minus 54. That is the idle time for machine A. Idle time for machine A 88, total elapsed time minus total process time on machine A 54. So what is the difference? 34 minutes. So this is the idle time for machine A. In the same way, we are going to find out idle time for next machine, that is machine B. See the solution table. See the solution table. In order to find out the idle time for machine B, we have to check in 3 different ways. The first one is the first job in time is 10 minutes. No, the 10 minutes is the waiting time, that is idle time for machine B. Okay, and that is the first way. And the second one is during the process, is there any idle time? That you have to check by comparing the in time and out time of the previous job, that is 16 and 14. So 2 minutes is the idle time for machine B. And the next one 24, no idle time. So 40, 30, 10 minutes idle time for machine B. And the next process 54, 50, here 4 minutes. Okay, this is the idle time during the process. This is the second case. And the third one is the last job process, the end time is 56 minutes. Now we need to compare with the total elapsed time. So that is also one kind of idle time for machine B. Okay, now see the calculation. See the working note for idle time on machine B. Okay, so machine B started is the first process in the 10th minute, that is the idle time. Okay, and the next one, during the process also idle time is there, that is 2 minutes, 10 minutes and 4 minutes for different jobs. Okay, and the last one is the process completed in the 56th minute. Now we need to compare this duration with the total elapsed time to find out the idle time at the end. Okay, so 88 minus 56 is equal to 32 minutes idle. So total idle time for mission B is 58 minutes. Okay, say idle time for mission B is 58 minutes. Now in the same way we need to find out idle time for mission C. So mission C's idle time can be calculated in two different ways. The first one is the in time for the first job, that is the idle time, that is 14 minutes. Okay, and check is there any other idle time during the process. For that you have to compare the current job in time and previous job out time. 26 no difference, so no idle time. 40 no difference. 60 no difference. 78 no difference, so no idle time during the process, only in the beginning. That too 14 minutes is the idle time for mission C. Okay, see, we have found idle time for mission A, B and C. For mission A 34 minutes, for mission B 58 minutes, for mission C 14 minutes. Okay, now look at the problem. So far we have done optimum sequence, minimum elapsed time and idle time for the three missions. Now we are going to find out waiting time for the jobs. Okay, see the solution table. Okay, now we are going to find out the waiting time for the job. For that we need to check each and every jobs. Okay, so out time and in time, out time and in time for the mission A, B and C. Okay, see the first job, the out time on mission A is 10 minutes and in time for the next mission is 10. So there is no waiting time. See the next one, here the out time is 14, the next in time is 14. So there is no delay. Okay, waiting time is not there for first job. Okay, look at the next job. Okay, the out time for the first process is 16 minutes and in time is 16. So no waiting. The next one, out time 24 and in time is 26. Here the next job has to wait for 2 minutes for mission C. This is the waiting time for this particular job on mission C. The next job, the out time is 24, in time 24, no waiting. 30, 40. So here 10 minutes waiting time, that too for mission C. And the next job, out time is 40, in time 40, no waiting. 50, 60, here 10 minutes. So the second job has to wait for 10 minutes, okay, to process through mission C. So 10 minutes waiting time. See the last job, see the out time 54, in time 54, no waiting. Okay, the next process 56 out time and 78 is the in time for the next process. So here this particular job has to wait for how many minutes? The difference is 22 minutes. Okay, so this is the waiting time for the last job on mission C. See the calculation for waiting time for the 5 different jobs. Okay, for job 4 there is no waiting time, so nil. For job 1 it has 2 minutes waiting time to process on mission C. Okay, job 5 has 10 minutes waiting time to process on mission C. And the next one, job 2 has 10 minutes waiting time to process on mission C. And the next one, for job 3, 22 minutes waiting time to process through mission C. Okay, so total waiting time is 44 minutes is the waiting time for all the 5 different jobs. Okay, see, so far we have done these things. Okay, the first one is total minimum elapsed time 88 minutes and idle time for A, B, C 34 minutes, 58 minutes and 14 minutes. And the third one, waiting time for the all 5 jobs is totally 44 minutes. Okay, hope you understand this concept.